Hello and welcome back to my bench. Today here on the bench we have a Yaesu FT1000MP Mark V field, and this radio came in with no transmit on all bands. So, okay, let's check if that is true. Okay, first of all, it is switched to the 20-meter band, and well, here we have the microphone, and we are on SSB upper sideband, and pushing the PTT clearly shows that the radio is switching between transmit and receive. So that is our first information, that obviously the processor is working in some way. So let's switch it, let's say, to frequency modulation and see what it means. So here's squelch. Squelch is now closed, and yeah, let's see what it means. Okay, so therefore let's have a look on our power meter, and yeah, as said before, radio is switched to FM, and let's push the PTT. FM is selected, and as you can see, yeah, there is definitely no output power. So let's switch to another. Let's switch to another band. Yeah, let's simply go to 7 megahertz, so 40-meter band, and we simply do the same. Radio is switched again to FM, and no power, so now I switch it to AM just in case, but also while I'm switching or pushing the PTT, so there is definitely no power. Let me do the same on different bands. Now I'm on 28 megahertz, so on the 10-meter band it is set to upper sideband. No transmit. So back to FM, and also on FM there is no transmit. So well, the description seems to be right, so we can reproduce the fault here in the lab. There is definitely no output power. Well, second test, what we want to do is, does the receiver work? So if the receiver will work, it is very important for us, because that will tell us a lot about the PLL circuit and the local oscillators. So if that will work, we know that PLL is not unlocked, and that is important information, because sometimes a radio will not transmit because radio is unlocked, or PLL is unlocked, and then there will be no drive frequency, at least, and therefore if the PLL in RX is working, it is most likely that the PLL will also work during TX, and then we get a better feeling where we should start searching for the fault. Well, and as already said, I'm on the 10-meter band, 28 megahertz upper sideband, and the generator is set to 28001, which should give me the 1 kilohertz tone on the radio if the receiver is working. The generator is set to minus 73 dBm. That means it is set to a level of S9, and yeah, let's check if the radio works. Well, and yes, what you can see here is that the S meter is showing S9, so that is a very good indication for the receiver. Yeah, let's crank up the audio amplifier a little bit. Yeah, and what we can say so far is that the receiver is definitely working, and everything seems to be good. So therefore, yeah, we do not have a problem in the PLL circuit. Everything looks fine so far, and now we know there is something else somewhere in the circuit, and yeah, let's try to figure out. Well, another test before we should go ahead and open the radio to look inside. We should check the setting in the menu, because in the menu you are able to switch off the power amplifier, and just in case that nobody has accidentally switched off you know, the power amplifier, we should check it, and therefore we have to press these buttons, and now you see we are in the menu. So now we are in the programming mode, and let us go to 8 point something. I don't remember exactly, but I know it is somewhere around 8. So here we are at 8, and somewhere here. No, I'm totally lost, so that was wrong. So let's go again and see. That is, no, I can't find it. Can't find it for the moment in time. So nope. Ah, yes, that it is. That is a power amplifier. So 8.3 is the right number. So that is a power amplifier, and here you can see power amplifier is switched on. So we can switch it off, as you can see right now. Now the amplifier wouldn't work, so for transverter use or what have you. And if we put it on, then the power amplifier is switched on. So this is definitely not the problem. So I can go back, and yeah, what you see is that we are back in normal use. Let's go back into the menu, and yeah, it is still on, so the power amplifier is switched on, so that is not the problem. And of course the RF power pot is set to maximum, so that is not the problem. The radio should transmit, but it does not. So next is let us crack it open and see yeah, what we can find. Well, here we have our two antenna inputs or outputs, and well, maybe the antenna input has a problem, but you know, because we have receive, so that is what we discovered before. We know that the switching here over the relays must be okay, and when I switch it to input B, you clearly hear that the receive stops, so that means going back to A, and it is directly back, so that means this switching here is working. So now we need to have a closer look to our power amplifier, or let me better say to the input of the power amplifier, because what we want to know is there, let me turn it down, is there at the input, is there any power visible from the stage before or not. So that will be our next step. Well, we are in. So this is a power amplifier, and before I'm gonna start do some more measurements, I just wanted to see if there is something obvious, and no, it isn't. So everything looks quite nice. There is no obvious sign of well, having a problem somewhere, so there is nothing burned, cooked or whatever, so it looks that everything is really in a nice order. So yeah, okay, that's it for the moment. So I'm gonna now close it back, and then we will check if we have an input signal towards the power amplifier. Okay, radio is switched on, and yeah, it's a little bit difficult to read, but it is switched on, so that is clear. So let me check. Yeah, you can hear it. So radio is on, and I am interested right now if we have our voltage supply for our final stage. So this is the supply here for the final, and yeah, what I want to see is if we have at least our voltage available. So therefore I have placed the meter right there, and yeah, let me check if the final stage will get power, and therefore So where is minus? It is over there. And yes, we are getting 13.9, so approximately 14 volt. And well, radio is switched to FM, and our power meter is connected to the radio. And now I will switch to transmit, and even on transmit the power supply towards the power amplifier stays without any change. So that means we can be sure that the power supply at the power amplifier is available. So next will be to check the drive. So okay, as already said, we want to check if the drive power here from the RF unit will give us a significant drive signal, and therefore I have here my unit in place where I can check the RF power. This here is a small dummy load that we measure into a load of 50 ohm. And down here, so let me go a little closer. Hope that you can see it. So I'm picking the signal here directly from the RF board, and normally this plug here will be connected to this point, and as you easily can see, this is the little coax wire which goes into the power amplifier. So this is the drive line, and what we need to know to go ahead in our fault finding procedure, we need to know if we have drive down here, because if drive is available here at the RF unit, then we can be nearly sure that we have a problem here in our PR unit, and yeah, so that is only consequent that we first of all check if the power is available down here. Okay, and what you can see up here is our level meter, which is connected as described. The radio right now is switched on. And now I want to switch the radio into transmit, and I expect a level of about 10 up to 15 dBm, which would be a nice drive level. So yeah, that is what we want to see, and now I switch to transmit, and yeah, perfect. So what we can see here, we have 11 dBm, and 11 dBm is definitely a power level which is sufficient to drive our power amplifier. And knowing this, we really need to investigate more in detail our power amplifier. I mean, still it can be that our TX RX switch doesn't work. So what we need to know next is if we see the TX switch coming up and supplying the power amplifier with voltage and current, of course. But up to this point, we can say that the radio is working so far. And well, on the other hand, what we can check else is if this 10 or 11 dBm, what we see there, is a frequency of 28 megahertz, because that is what we have dialed in, and that is what we should check as well. Okay, counter is connected to the RF unit to check if the right frequency is available at the pickup point for our power amplifier. And yeah, we had our 11 dBm, which we declared as right. And now I've connected the counter, and the radio is set to 28 megahertz. And what we want to see, if I key the unit, that we can read our 28 megahertz. So now unit is keyed, and yeah, so what we can see, radio is 19 hertz off, and it is dropping. So yeah, so this is 17 hertz, and that means radio is producing the right TX frequency. So PLL circuit seems to be okay, and well, PLL circuit is locked because it is not jumping or whatever, so it is nice and stable, and well, that it drops is normal, because circuit is heating up a little bit, and if temperature is increasing, then the frequency stability is getting better. So anyway, what we can say so far is that PLL circuit is working. It is definitely locked. Frequency stability is more than good in limit. I mean, 13 hertz off is quite good for a radio, so no problem whatsoever. And we know that the level which we are giving or putting here into the counter is 11 dBm, and that is definitely the right drive value. So yeah, it is confirmed for, let me say, 97% that we have a problem inside our PA box, and what we need to do right now is to investigate our power amplifier box. Here inside we have our low pass filter as well, so it could be that something is wrong with the low pass filter. So there are definitely some other faults which can cause this problem, and so now we need to go step by step through this unit and see what we have. Well, I just want to show you this. To get off this metal here, you need to peel off this copper, and you can't use it again. So this is not very nice. So from my point of view, this is not really what you expect from a radio like this. So this is, you know, it is, you need it because you need to close the box that no interference can happen. But as they have done it, you know, that is really hopeless. I really don't like it, and it is sure we need to we need to do something different. But yeah, that is not nice. Yeah, we are in after destroying the copper. Oh my goodness. Okay. This here is, as we have seen it before, the power amplifier board, and this here is the low pass filter board, and this wiring here is to switch all the relays depending on the band you are working on. And here we have the antenna switch, or better said the TX and RX relay. And well, here is the input into the power, this is the input into the low pass board, and here this is the output out of our power amplifier. And yeah, so what we need to check first is if finally all voltages are available, and if the TX switch is switching the power amplifier to transmit. So that is now the first we have to do. Okay, according to the schematic of the power amplifier, we have down here our TX switch input. So have a look. Here we have to have a positive voltage to get this digital transistor switched, and then we will finally get our bias voltage. And of course it is not only the bias voltage, it is also the power supply for our pre-driver. Oops, you can't see it, sorry. Once again, so this here is the transistor which get engaged by the TX switch. So yeah, as I said, we need a positive voltage, I guess 5 volt. Then we get this transistor switched, and then if we follow here the trace, we can simply see that this is the operation voltage for our pre-driver, and as well it is the power, the bias voltage for our driver stage, which is this here. And of course, if we see this here, it is the bias voltage for our final stage. And first what we need to check is if we have a positive voltage here at the input to this digital transistor, and this is definitely needed to get the complete amplifier engaged, and to get finally the pre-driver fired up. And according to our schematic, the connector J6103, which is this guy here. So this guy is at least the input from our TX switch, and red wire is ground. So that is really unusual, but it is like this. And the white wire here is at least the input. So if we go to transmit, the radio itself is switched on, and it is set to FM. And if I will now push the PTT, we should see here the TX switch voltage, and therefore let's watch our multimeter, and here is our PTT, and I'm probing the input as described, and now I'm switching, and let me double check if the radio goes into transmit. Yes, on display I can clearly see that the radio is switching to transmit, and you can hear maybe that some relays are switching, so something is definitely going on. But as you can see here, we do not get our TX switch, and without having our TX switch engaged, we do not have supply voltage at our preamplifier, and that means our preamplifier doesn't work, and the rest of the circuit does not get bias, but bias is for the moment in time not the problem, because the transmitter would work without bias voltage as well, but without the power supply for the pre-driver, the complete power amplifier will not work. So what we see here is that we have definitely a problem with our TX switch. So what we need to find out right now, I mean, if we follow this wire here, we can see that it comes here from the low-pass filter board, and now we need to understand when and why we get voltage to this wires, and without any TX power available, or not TX power, sorry, TX switch voltage. So that is what I mean. We need our TX switch voltage to this point to get our digital transistor engaged, and then finally our complete power supply lane, which needs then, or power supply bus, however you want to call it, to power up, to fire up at least the power amplifier. So there is the fault. I'm sure if we put power or voltage here on the TX switch line, then it would work, but for us it is now important to understand why we do not get this switching voltage. Okay, according to our schematic, this connector down here is the connector which goes to the power amplifier PCB, and T9 down here obviously stands for 9 volt DC, I guess. So there is nothing special on this board. So what we can see here, that we have a link to this connector, and I have already looked it up in the schematic, and so this is an output as well. So this is not the connector where we get our 9 volt or whatever T9 means from the microprocessor board, because, you know, if we key the PTT, then we see on the display that the TX is switched on, and from the microprocessor must come an high to tell at least the power amplifier, okay, just go in transmit. And I have identified the J6004 as input. So that means on pin 2, it is pin 2. If we look to this point here, so this must be our TX input, and when we are keying the PTT, we should have here, I guess, 9 volt, which then will be the supply for our power amplifier PCB, and so this is the output where we already measured, probed our voltage, and it was not available. So what we're gonna do now is checking if the voltage, the transmit voltage, will be available at the J6004. So that will be next. Okay, so then let us find the J6004, and well, I've already found it, and it is this connector down here. So what we need to know right now is, do we have a voltage here on pin 2 during keying the PTT? So that is what we need to find out, and let me bring the meter back into the field of view. So now we have still the probe at pin 2, and again here is my microphone, and I'm keying now the PTT. And have a look, here we have our switching voltage. Yeah, that is great. So so that means a switching voltage is available on our low-pass filter board, so you can clearly see that we have 7.5 volt, so it is not 9, but 7.5 is definitely enough to switch our digital transistor to get our power amplifier engaged, and that is what we need. The question is now, why is it not on the other socket? So let us check the other socket as well, and therefore let us go back down here. So what we already have found out is that the white one should be our 7.5 volt, and the red one is ground. So that is what I've checked before. So now let me put my probe down here, so it is now where we should have our 7.5 volt, and now I take again my PTT, and you can see it now. You see, so we do not have our voltage at this point, and that's the reason why the radio does not go into transmit. So that is definitely the problem, and we know from our test before that we have our voltage here on this connector. So let us therefore once again check at this point, just in case. So we have done it already before, but just in case. So I'm again on the white wire. So that is what we want to make sure that we do not have a problem with the wire which is going over to our PA board. So this guy here. So let us check the voltage here as well, and yeah, we do it again, and here we have exactly the same problem. So there is no voltage. Okay, and now once again let us go back here to our connector to pin 2. So now I hope I'm down at pin 2, and let us do once again exactly the same. Yeah, and you can see here is our TX switching voltage available, but it is definitely not where it should be. So, well, I think that is good news, because we know the switching voltage is already here on our low-pass filter board, but it is not down here that it is able to supply our power amplifier. So that is what we need to investigate right now. As we do not see anything obvious here on the top of the PCB, the only way to go a bit deeper in the circuitry is to take it out. So maybe we are lucky and it is a kind of dry solder point or such, you know, because there is nothing really complicated in between. So it is a direct link from this connector down to this connector. So there is really nothing special, and normally if we would now directly put a link from here to there, it should work. But anyway, we should better investigate what's really going on, because then we are sure that problem is fixed. Okay, here we have our board. So this is the solder side, and this here is the connector. And for me it looks like that the connector is not really good. So what I'm gonna do right now is I'm gonna reflow it, and we want to check it afterwards. So if we are lucky, it is the bad solder work. I mean, it is difficult to see through the camera, but I have watched it through the magnifier, and it does not really look really good. I mean, it is not definitely to see that something is wrong, but on the other hand, this solder work is really bad, and from the experience I know this is very often the reason for problems when you do not have right connection or whatever. So I gonna reflow it right now down here, and I gonna check all the other solder work as well, and well, afterwards we will reinstall it, and if we are lucky then we get it fixed. Otherwise, if it don't work by simply reflowing it, I will directly put a wire to the other connector to be sure that we get our needed voltage over. But that we will check after it is reflowed. Okay, solder work is done, and it is already cleaned. So we can now put it back into place. So that needs to, there is a screw which we need, and now we have to put it back and screw it back into it, and then yeah, we hope that our voltage will be available, and well, we have really a good chance that it will work, because you know, it was clearly to see that the solder work was very bad. I just put in only 2 screws right now, and I just bring back all the connections, and then we will make a test. If the test is positive, I can then put back the other 2 screws which are missing right now, and yeah, so let's see if it works. Okay, so the wiring is back in place, and I will go down here to the point where we need our 7.5 volt, and okay, so you can see the meter, and now I will push the PTT, and hey, have a look. Have a look, our 7.5 volt is back, so it was definitely a bad solder point at the connector. Very nice. Okay, so that means right now I can put this lead back to the power amplifier like this, and if everything is good right now, we should be able to read the power output at our LP100. So normally, if nothing goes wrong any longer, we should have a working power amplifier, and therefore here is our microphone, and watch the power meter when I'm pushing the PTT. Hey, is this nice? So that is what we wanted to see. So transmitter is back in operation. So it was definitely the missing TX voltage which is needed to switch the transmitter from receive to transmit. And now you can clearly see it is working again. So that is what we wanted to see. Well, we cannot really put too long power out because our ventilator, so our cooling system is not working because it is disabled from the rest of the circuit. So now we need to reinstall everything. I should not forget to put the two screws into here. I will put back the shielding, and we need to put something at the edges to reduce interference. Then we have to put back the amplifier back into the housing. Then we put back the fan, and well, then the repair should have been done. Okay, so it is closed right now, and now we need to seal the box that we protected against interference, and we gonna use this aluminium band and put it around nice and complete, and then it should be okay, and then we can reinstall it into our housing. Okay, our tin is closed, so we can go ahead. Okay, everything is back in place. The power amplifier and of course our fan. So now we can do a final test to see if transmitter is working as it should, and then we can close our housing if everything is okay. Radio is set to upper sideband, and I now want to check if microphone circuit is also working. So well, therefore let's watch our power meter, and taking the mic, and let's check. Okay, 1 2 3, check check check, 1 2 3. Audio 1 2 3, check check check. So okay, seems to be great, it's working, and well, that is what we wanted to see. So SSB is working, and now let's switch it to amplitude modulation. And whoa, the dead key is very high, so that needs to be a bit reduced. Okay, great. Check, 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 check. 1, 2, 3. Check, check. Okay, 1, 2, 3. Check, 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 check. 1, 2, 3. Okay, so that is working as well. So from that perspective, everything is working as it should, and that means radio is back in service. Our power amplifier is working again, and what we have learned, it must not consequently be the power amplifier itself, so dead finals or what have we. Sometimes it is really something very, very simple, and that is really the learning out of this video. So only a simple missing voltage makes this problem that you think, well, do I have a dead final or what is it? But no, it was simply a missing voltage. Okay, so we are really at the end of this video, and if you like it, please give me a big thumb up and catch you next time. Bye!